Welcome to The Explainer. Today we're going to tackle a really crucial skill for any programmer, writing code that doesn't just work, but actually survives in the real world. We're going to explore how to build resilient apps that can handle the unexpected gracefully, turning what could be a total disaster into just a minor hiccup. Okay, let's get into it.
We've all been there, right? You're using an app, you click something, and bam, it just freezes up, or maybe disappears completely. What's usually happening behind the scenes is something called an unhandled exception. You can think of it as the program running into a problem it has absolutely no idea how to solve, so its only choice is to just give up.
So to write code that won't break, we first have to understand how it can fail. And believe me, not all errors are created equal. Figuring out the different types is really the first, most important step toward building software that's truly solid. There are really two main kinds of errors. On one hand, you've got syntax errors. These are basically just typos or grammar mistakes in your code. Your computer sees them and says, nope, I don't even know how to start this. But then you've got runtime errors, or what we call exceptions. This is where your code is grammatically perfect, but something totally unexpected happens while it's running. These are the sneaky ones, the dangerous ones, and they're exactly what we're focused on today.
So what exactly is an exception? The best way to think about it is like an alarm bell. When a program is running along just fine and suddenly hits a wall, a problem it can't solve, it rings this alarm. It throws an exception. And if there's no code listening for that specific alarm, well, the whole thing just comes crashing down.
And these alarms, they can be set off by all sorts of things. Trying to divide by zero? That's mathematically impossible. So, alarm. A user types banana where you were expecting a number? Alarm. Your code tries to open a file that isn't there? You guessed it. Another alarm. Each one of these has a specific name, and any single one of them can bring your app to a screeching halt if you're not ready for it.
All right, so if these exceptions are pretty much guaranteed to happen sooner or later, how do we stop them from blowing up our programs? Well, we build a safety net right inside the code itself.
Let's just look at a classic piece of vulnerable code, 10 divided by 0. As you can see, the syntax here is perfect. There's nothing grammatically wrong with this line, and yet it is absolutely 100% guaranteed to crash the second it runs.
And when it does run, this is what the user gets. A crash, and this big, ugly, intimidating error message. It's a terrible experience, and it just kills the program instantly. We can do so much better.
This is where the try except block comes in to save the day. See what we're doing here? We wrap the risky code, the part that we think might fail, inside a try block. This is us telling the program, hey, give this a shot. Then if it fails in a specific way, the except block kicks in and provides a backup plan instead of just crashing. The logic here is so simple, but it's incredibly powerful. The program runs the code inside try. If it all works out, great. It just skips right over the except block. But if that alarm bell goes off, it immediately jumps down to except, runs that code instead, and here's the magic part, the rest of your program just keeps on running like nothing happened.
Okay, let's take this one step further, because in a real-world app, your code can fail in a bunch of different ways. A single safety net just isn't always going to cut it.
Just imagine you're asking a user to enter two numbers to divide. What could go wrong? Well, they might type in some text instead of a number. That's one problem. Or they could enter 0 as the second number. That's a completely different kind of problem. We need a way to handle both of them, but handle them specifically.
And we can do exactly that just by stacking our except blocks. We can have one ready for a value error, which catches the bad input. We have another one ready for the zero division error. This lets us give really specific, helpful feedback for each type of problem. And it's always a good idea to have a general except block at the very end as a catch-all, just in case something happens that you didn't see coming.
Okay, now for the truly professional touch. What about the code that you need to run no matter what? Code that absolutely positively must execute whether an error happened or not.
For that, we have the finally block. Think of it as the ultimate cleanup crew. It runs no matter what. This is so important for things like closing a file you opened, or disconnecting from a network. If you forget to do that, you can cause resource leaks, where your program just holds on to system resources and slows everything down. The finally block guarantees your cleanup code always gets a chance to run. Now this slide is really interesting because it shows you exactly how the program flows. Look at scenario 1. Everything works, so it goes from try straight to finally. Now look at scenario 2. An error gets caught, so the path takes a detour through except, but it still ends up at finally. And here's the wild part. Even in the worst-case scenario where an unhandled error is about to crash the whole program, you can see finally still gets to run right before it all goes down. It's your one absolute guarantee.
So, let's just bring all this together. Why did we just spend all this time planning for things to go wrong? What's the big payoff here? Here's the bottom line. Exception handling is what separates a fragile little script from a truly robust application. It's what prevents those jarring crashes. It creates a much better, more forgiving experience for your users. It allows your program to recover gracefully. It makes sure that critical cleanup always happens. Honestly, it's the mark of professional, reliable, high-quality code.
So think about a program you're working on right now. Where could a user enter some bad data? What file might go missing? By thinking ahead and anticipating these failure points, you can use try, except, and finally to build a stronger, more reliable, and just a far more professional application. Thanks for watching.